At 9:13 a.m., a sports car is traveling 36 miles per hour. Okay, so let's say 9:13, 36 miles per hour. Okay, and 2 minutes later, at 9, so that would be 9:15, the car is traveling 83 miles per hour. The mean value theorem guarantees that at some time during this 2-minute interval, the car's acceleration is exactly a miles per hour squared. So we're looking for what is that value of a. There is one acceleration value that's guaranteed by this change in velocity over these 2 minutes. Okay, so let's focus on that word minutes. That's the first thing I notice here, is that we're talking about hours and minutes in the same problem. That we can't do. So we have to convert everything to either everything to hours or everything to minutes. I think it makes sense to convert to hours because we think about the velocity of a car measured in miles per hour, never miles per minute. So we have to take those 2 minutes and convert that to hours. So 2 minutes, well, 2 out of the 60 minutes. So that's 2 out of 60 hours. We'll reduce that to 1/30th of an hour. All right, so that's our time difference. So we'll say change in time is 1/30th of an hour. All right, and so now we have the mean value theorem. So the mean value theorem says that f prime of, we'll say f prime of c is equal to f of b minus f of a divided by b minus a. So it's basically saying at some point in the interval a to b, so we need, there's a couple of criteria that we just have to always consider. The function is continuous on the closed interval a to b and differentiable on the open interval a to b. Okay, so let's sort of restate this, the mean value theorem in the context of this problem. So we're talking about the speed, we're talking about velocity, v of t, and what the mean value theorem says is that v prime of, I'll say v prime of t is equal to, well, our interval. So let's say our interval from 9:13 to 9:15. So let's say at 9:13, we'll call that t equals 0. And so at 9:15, that's 1/30th of an hour later, that will be 1/30. Okay, so v of 1/30th minus v of 0. So it's the ending velocity divided by the beginning velocity divided by the change in time, which is 1/30th minus 0. And we're given that the ending velocity that's given in the problem, that's the 83 miles per hour. So we have 83 minus the 36 miles per hour, and that's divided by 1/30. Okay, so we have to plug that into a calculator. And when we pop that into the calculator, we get 1,410. And what do we know about the derivative of velocity? Well, the derivative of velocity is acceleration, and that's what we're looking for. So at some point, a of t, acceleration, is equal to 1,410 miles per hour squared. All right, and that does it for this problem. I think just want to recap. The most important thing was the first thing we did was to notice that we were given information in minutes and also in hours, and we had to do a little conversion so all of our values were consistent in terms of their units. All right, that does it for this one. I hope this was helpful.